All right, let's look at some math. We will cover the converse to the Pythagorean theorem section of Math 8, Term 2. Let's jump right into it. So, essentially, what's a converse? Well, yes, it is a type of shoe, but when we're talking about it in terms of like math and science and those kind of things, a converse is basically the opposite, okay? It's something stated in the exact opposite way, okay? So, for example, with the Pythagorean theorem, right? We basically say, we've got the a squared plus b squared equals c squared, right? That all these sides of a right triangle are going to be connected with this formula, okay? So the converse to the Pythagorean theorem is kind of going the opposite way. It's saying if we have three numbers, we'll do 3, 4, and 5, so that 3 squared plus 4 squared equals 5 squared, then we can say that it forms a right triangle. Okay, whereas before we say it's a right triangle and then we can use that idea. This one's going backwards, saying if those numbers work in the Pythagorean theorem, then they also form a right triangle, okay? So that's essentially what we're going to do. We're just kind of working backwards with that Pythagorean theorem, okay? Just a few things to remember. The longest side is always going to be the C, the hypotenuse, which is across from the 90-degree angle, right? Always across from that. The A and the B are just legs, and that they're, going to be the smaller numbers. Now, it does have to happen that those smaller numbers, when added together without squaring them, are bigger than that third number, okay? Because you could run into a situation where it wouldn't actually form a triangle, even though those numbers could work. But we're not worried about that so much this time, so why don't we just see some problems and kind of take it from there. So, workers at the Pythagorean Construction Company, clever name, are building a new house. They need to make sure that proper right angles are formed to ensure that a safe house is built. What statement should the builders use to ensure that right triangles are formed? Okay, basically we're just saying kind of what about this Pythagorean theorem? The sum of the two shorter sides equals the longest side, okay? So that would be like A plus B equals C. We definitely know that that one's not true. If the sum of the squares of the two longer sides equals the square of the shortest side, okay, then the triangle is a right triangle. We should catch that one's wrong as well because it says the two longer sides. So that would be like the C plus B, when they're both squared, equals A squared, okay? And we know that's incorrect, okay? If the sum of the squares of the two shorter sides equal the square of the longest side, okay, that's what we're looking for, right? That's the Pythagorean theorem. So it should be this one. And let's just double check with the last one. If the difference of the squares of the two shorter sides, okay, the two shorter sides wouldn't work, right? Can't be the difference of these two shorter sides. Now, it could be the longer side minus one of the legs, right? The hypotenuse minus one of the legs. That would actually work, but that's not what this one is saying, okay? So just kind of reviewing if we can, using words, understand what the Pythagorean theorem was. Okay, Kelsey measured the sides of a porch to determine if it is a right triangle. Does her porch with side lengths of 42 feet, 56 feet, and 70 feet form a right triangle? Okay, well, so we take the longest one, 70 squared. It's going to be by itself. Then the other two, 42 squared plus 56 squared. Okay, are they equal? Okay, well, that's what we've got to test. Okay, so we get out a calculator and go 42 times 42, which is 1764 plus 56 squared, or 56 times 56, which is 3136. And add those two together, and that becomes 4,900. So what is 70 squared? Well, 70 times 70 is that same exact thing, which is what we wanted, right? Because the question was, were they the same? And yes, They are the same. So yes, it's a right triangle because that is true. Okay, because that is true. All right, Darnell is constructing a rectangle window frame. He measured the length, the width, and the diagonal as 26 inches, 32 inches, and a square root of 1,700 inches, because apparently that's how his stuff works. He used the drop-down menus, I eliminated those, to answer the following questions of the Darnell's window frame. So what is the longest side? Okay, well, basically we've got to see what is the square root of 1,700, okay? Because if we don't know what that is, it could be our longest side, but it may not be. So I take the square root of that, and it ends up being something like 41.23. So we've got 26, 32, and 41. So the longest side is the square root of 1,700, which approximately is 41.23. So what's the square of the longest side? Well, that one's easy, because anytime we have a square root and we square it, they cancel out, and we're just left with what was under it. What is the sum of the squares of the two shorter sides? So basically, we're basically doing the same thing, just it's having us do it a piece at a time. Okay, so basically it's saying what is, 32 squared plus 26 squared. So now I do 26. Add those two together. And surprise, surprise, we get 1,700. So does it form a right triangle? Well, yeah, that longest side squared is that. The two shorter sides squared and added together are that. So yes, it does. All right, Gerard concluded that the triangle with sides square root of 95 feet, 8 feet, and square root of 150 feet cannot be used as a building frame, support on the house, because it is not a right triangle. How did he come to that conclusion? Okay. Well, essentially, we've got to figure out, which one is bigger, which I know square root of 150 is going to be bigger than square root of 95. I also know 8 squared is 64, okay? So basically, the square root of 64 is kind of how it fit in with those other two. So this one's the smallest. That's the second smallest. There's our hypotenuse. So is our hypotenuse squared going to be equal to the two sides squared? Okay, now we know 8 squared is 64. The other two are easy because we just take when we square the square roots, right? We get rid of it. So 95 and 64 added together is actually 159. So we get 150. Does it equal 159? It does not. Okay, therefore Gerard was correct in in proving that it wasn't a right triangle. Okay, so how did he come to that conclusion? By squaring and adding the shorter sides, seeing if it's equal to the square of the longer side. Okay, Ella is checking roof frames to make sure that they are right triangles. Which of the following measures form right triangles? Select all that apply. All right, so we just start working through. So the longest one, right, needs to be the one by itself. Okay, so we just start at 1 and go from there. So 10 squared, 10 times 10 is 100. That's an easy one. 24 squared is 576. And then 26 squared is 676, which we should be able to say that's 676. They are equal. So that one is. Okay, now we do our next one. Now, how do we tell what one's bigger or smaller? Well, what's the square root of 20? Square root of 20 is about 4.47. About 4.5. So there's our biggest. So 8 squared plus square root of 20 squared. Does that equal 25 squared? 8 squared is 64. Square root of 20 squared is 20. So that's 84. What is 25 squared? It's 625. So definitely not going to work on that one. Okay, next one. Now what's 161? The square root of 161, it's about 12.6. So 15 is our bigger number. So 8 squared again plus square root of 161 squared. does it equal 15 squared? So 64 plus 161, does that equal 15 squared? That would be 5, that would be 12. So does 15 squared equal 225? It does. So we've got a right triangle there. Next one, there's our biggest one. That one's easy to see, right? So 20 squared plus 21 squared, is that equal to 29 squared? So 20 squared is 400. 21 squared is 441. So 400 plus 441 would be 841. Is that what 29 squared is? So 29 squared is 841. So yes, it is. Okay, so when you're checking three numbers, that's all you're doing is just simply plugging them into the Pythagorean theorem formula and checking to see if they come up to be the same thing. So 89 squared, we'll do that one first. 7921. 80 squared is 6400. And 39 squared is 1521 plus 6400 equals 7921. So yep, I'll accept that one. So just kind of a lot of work to get there, but basically we're doing the same thing over and over. All right, Bryn checked the measures of the stairs to make sure they formed a right triangle. The measures of the steps were 5, 13, and 12. Bryn's work is shown below. Her conclusion is that it's not a right triangle, okay? So do we see a mistake? You should. Maybe if I highlight that, will that help? Or if I highlight that, or if I draw arrows. She mixed up which one should be where, right? So it should be 5 squared plus 12 squared equals 13 squared, because 13 is the bigger one. So it'd be 25 plus 144. Does that equal 169? Which it actually does. So her conclusion was incorrect because, and this kind of shows you why that hypotenuse always has to be the one by itself. Okay, always has to be the one by itself. All right, a shelf is designed so it will fit in a 90-degree corner between two walls. The shelf has dimensions rounded to the nearest tenth as shown. So basically, it's got kind of a triangle here. The question is it a right triangle? Okay, so will it fit snugly in a 90-degree corner? Well, I'd go 11 squared plus 11 squared, because that's the one we're hoping is the 90-degree angle. Does that equal square root of 242 squared? Okay, well, 11 squared is 121. So we've got 121 plus 121. Does that equal, and let's see those cancel, 242, which 121 plus 121 is 242. So yes, it will fit because not any of those. Yeah, and they just, same thing. So they just went 2 times 11 squared, same thing. Okay. All right, Nadine is making a quilt. She can use a rectangle of any length and width as long as the angles in the shape are right angles. Which piece of fabric can Nadine use in the quilt? Check all that apply. So basically, we kind of already proved this one, didn't we? 5 squared plus 12 squared equals 13 squared. That's 169, 144, 25, and yeah, 169 does equal 169, okay? So fabric 1 is a go. Okay, what about fabric 2? Oh, we're moving to the right here. 8, 6, and 10. So it's 8 squared plus 6 squared equal 10 squared. 8 is 64, 6 is 36, 10 is 100. 64 and 36 do equal 100. So fabric 2 works. Fabric 3. Okay, we'll do this one on this left side. So 3, 4, 5, and 6. So 4 squared plus 5 squared, does that equal 6 squared? So 16 plus 25, does that equal 36? And the answer is no, because that would be 41. So fabric 3 cannot work. Fabric 4, 10, 8, and 12. So 10 squared plus 8 squared, does that equal 12 squared? 100 plus 64 equals 144. And that would be 164, does not equal 144. So fabric 4 is a no. Fabric 5. 6, 4, and 8. 6 squared plus 4 squared, does that equal 8 squared? 36 plus 16, does that equal 64? That one might. Let's see. Nope. 52 does not equal 64. Okay. So that one doesn't work either. And fabric 6. 8 squared plus 15 squared, does that equal 17 squared? So 64 plus 225. Now 17 squared I don't have memorized. So 17 squared is 289. Okay, so if we take and add 64 and 225, that actually is 289 as well. So 289 and 289 work. So we've got those three, right? So it'll be 1, 2, and 6. All right. Which of these 4 sets of side lengths will form a right triangle? Okay, so same idea here, right? We're just going through and we are just going to solve these, okay? So set 1 would be, okay, now what's the square root of 12? Because we got to find our biggest one. Well, the square root of 12 ends up being 3.4. So that's our smallest side, okay? So 7 is our biggest, so it's going to be square root of 12 squared plus 6 squared. Does that equal 7 squared? 6 squared is 36. That's 12. 7 squared is 49. And that's going to actually equal 48. Does not equal 49. Okay, so set 1 is a no. Set 2, let's see. Okay, so we got the square root of 29, and we've got the square root of 35. So, honestly, what we could do is just say 8. I don't know, let's just go 29 square root is 5.4, basically. And 35 square root is 5.9. So, is the square root of 29 squared plus the square root of 35 squared going to equal 8 squared? So 29 plus 35, does that equal 64? I want to say it does. 14, yep, 64. So set 2 works. Okay, what about set 3? So square root of 5, square root of 3, 4 is 16. 4 squared is 16, so that means that that's going to be our biggest one, okay? So, square root of 3 squared plus square root of 5 squared, does that equal 4 squared? Well, 4 squared is 16, that would be 5, that would be 3, only 8, definitely not going to work. And the last one, the square root of 26 is like 5.1. So there's our biggest. So square root of 26 squared plus 6 squared, does that equal 9 squared? 9 squared is 81. 6 squared is 36. That's 26. That probably can't get to 81, can it? 62 does not equal 81. So we were right with just set 2. Okay, Jackie plans to place a rectangular piece of art inside a rectangular frame. She considers a piece of art that is 0.5 meters long, 1.2 meters wide, and has a diagonal length of 1.3, which is true regarding this art piece. Okay, so basically, does it have a 90-degree angle, which would make everything else 90-degree angles, which would make it a rectangular piece? So we go 0.5 squared plus 1.2 squared. Does that equal 1.3 squared? Okay, so 0.5 squared should be 0.25 plus 1.2 squared is 1.44 equals 1.3 squared, which is 1.69. Okay, so then 1.44 plus 0.25, that equals 1.69. So yes. Okay, it's going to be a rectangle because, you know, you have this piece right here. The diagonal was the 1.3, 0.25, and 1.2, right, distances. So that means this is a 90-degree angle, which would then mean the rest would have to be 90-degree angles as long as everything was square, okay? I mean, you could argue that it's not necessarily true unless you try to look at everything else, okay? But basically, they are equal, so that is what we're going for, okay? All right, so hopefully this helped you out. Now you can get back to work making progress on your Edgenuity course, and let me know if you need any help, please.